Hi Alan, you're a speaker on Code Europe. Your lectures were about big data, about robotics. Can you briefly introduce your speakings here?
Sure. So I talked today about big data, searching the web on a massive scale, how to organize that data, and importantly, how a lot of the technologies that are underneath the concept of search have grown and have helped us to make what we have today, which is the cloud, which has dramatically changed the landscape of IT for developers everywhere. And the second topic that moved away from this giant big area was in a very small area, which is IoT and robotics, which is another thing that I'm involved with at the moment. The topic for this one here was pretty much about my journey as an engineer in building a robot, the things that I discovered, and how those map to things that I've learned in my career over the last 20 or so years.
The hottest topics now in IT industry.
The which?
Two of the hottest topics now.
Two of the
in
hottest
the industry,
topics, yeah.
Okay, so first question. What is your recommendation for the people who want to start the journey with robotics? Some tools, some ideas, some platforms, maybe some best practices?
Okay, so from a robotics point of view, the most important thing I think, first of all, is not just to jump in. It's to set yourself a small project, to do this, to do it well, and to move on to the next piece. To try and to take the different things about robotics and break these and deconstruct them into individual projects, so that when you get these individual projects finished, they come together as one whole and you have a robot. So for example, you could say, I'm going to go off today and I'm going to learn about image recognition. Because when a robot moves around the place, it needs to recognize what's there, how do I know what this thing is, how far is it away from me, am I going to collide with it, am I going to break with it, can I interact with it, can I say, hello, who are you, my name is Mr. Robot, etc., etc. So that in itself, recognition, image recognition is one project, which doesn't necessarily have to stay within the robotics field, has many other uses. Then you might do something like, I want to interact with a human, so how do I parse language? How do I talk to somebody? How do I use a service in the cloud like Microsoft Lewis that will help me to interact with somebody? How can I break down these languages, these sentences with natural language processing? And all these individual pieces, how do I then interact with a piece of a robot? How do I connect a piece of computing equipment to some hardware, like maybe a small motor, to move my robot around the place? How do I do this type of thing? And one of the fundamental small pieces that we can start with to learn and understand and play these games with ourselves is using something like a Raspberry Pi, Arduino, NetDuino, any of these simple tools. So we can learn these, we can interact with them as developers really easily, and we can learn the bits of hardware that we can then use to add together and build our robot.
Alright, so there are two point of views when you're creating a robot, the developer point of view and the mechanic point of view. So which is harder one?
I don't think, yeah, from an engineering point of view, both have challenges. I mean, from a robotics point of view, one of the things that we have to do is we have to say, how do we make our code very, very efficient? Because we've only got a small space to run all of our code, and sometimes we have to offload this and spread our processing wide rather than stack up onto one machine and maybe use a few different processors. So it's a different way of working than working on a big data side, and there's many problems. On the other hand, as a mechanical engineer, there's other challenges. How do you use the optimal weight in an arm to make sure that it's actually transportable? If you use a weight that is too heavy, well, you've got to have a sufficient battery to be able to move that heavy weight around. So each one has its own challenges, each is quite different. As I said in the talk, I'm mostly a software guy, so I'm more at home with the software, and I find the hardware stuff really interesting to go to a certain level, but when I need to go that little bit deeper, I'll reach out to a friend or a colleague who's more of an expert in this area, and I'll say, I have an idea, can you help me push it home, please? So I think like many things, it's not which is more interesting or which is better or which is harder. It's which do you have the expertise in, and where is your time better spent.
So can you recommend platforms like Lego Mindstorms for the beginners? That these platforms are ready to go out of the box?
Sure. If you go on to many of the websites and search for Raspberry Pi robotics, Arduino robotics, you'll generally get some small rover type robotics that you can start off with. And these are very simple things. They just have one simple board like a Raspberry Pi, a Pi Zero, an Arduino. It would have a small base ready cut with lasers, maybe some wheels, maybe some small camera or some lights or something on the front. And you'll start off with just learning the basics of how can I use some simple Python code, for example, to move it from here to there. You don't only have to start with hardcore stuff, let's say, like Raspberry Pi. There's also a whole selection of things out there in Lego. So Lego Mindworks is a great way to also start off with robotics and get used to things, especially for younger people who haven't gone to college yet, but you want to get them interested in this area, because let's face it, big data, AI, machine learning, robotics, it is the future.
Yeah, that's what I like. Your lectures on Code Europe were about robotics and big data. Where do you see the future of both of them connected together?
So the thing is, a bit like on a mobile phone, it's an underpowered device in comparison to a desktop, let's say. We can only do so much. And many times what we have to do is we take the little piece of processing that we have, and then we take the data from there and we offload it to a big cloud center, which does the real work of number crunching and making decisions, taking the result of that and sending it back down in a small data packet to the device. And in the same way, the interaction between cloud and robotics works, in that the robot can't possibly hope to do everything. If it could, it would be a tank, it would be too big, it would be too unwieldy, at least now at this moment in time. Sure, in 7 and 10 years' time it'll be different, but right now you need a lot of power to be able to do a lot of processing. So the best thing to do is to have an equal share between them, whereby we use the big power of the cloud to offload the processing that we need to do, and then just send back the instructions to the local robot.
And the delay problem?
The which?
Delay problem between.
Yeah, well, the delay problem is a problem that you have in engineering, whereby you say to yourself, I know I need to do something, I need to offload it, I need to be able to take care of this problem, but I can't get it done quickly enough. So what you do is you take intermediate decisions. You say to yourself, okay, I need to look forward. In 5 steps from now, I'm going to hit an obstacle, I'm not quite sure what it is, and I don't know what's going to happen when I get there. So maybe we take some image of this, we send it up to the cloud, and it's got 5 seconds to analyze what this thing is and get me the information back down again. So in this way we can take some information before it's actually going to happen, ask for advice, and get it down. So a bit like if we think about we have an aircraft coming into land, and the poor pilot has a heart attack. Oh, he's going to die, he's going to die. So the stewardess comes in and says, I can fly the plane. And he says, no you don't, I'm dying. Yes I can, talk me down. So there's a delay between, I'm going to die, and she guides him down. So in exactly the same way with robotics, we in many occasions have a little delay before we need to do something, and we can use that delay to our benefit to actually predictively look ahead. We can also use predictive analytics to say to ourselves, there's maybe 5 things that I could possibly do, which one will I do? And you ask these things of the cloud, it gives you all 5 answers, so no matter which one you do, you know which way to go. So in this way you can share the thinking between the cloud and the robot.
Now we are in the very close to the era of self-driving cars. Do you think about self-driving cars more in terms of big data or more in terms of robotics? Because there are not a lot of mechanics in there.
Actually, I don't think about self-driving cars either from robotics or data, because clearly we already have self-driving cars, and self-driving cars and the technology to drive them has been around for a while and will only improve. And there is no doubt in my mind that in 5 years' time we will see self-driving, mainstream in the same way as last week I saw my first Tesla driving in Ireland. I went, wow, that's really cool. But I saw one a few years ago in the States. So we'll see these things emerge in the same way as a car you buy now, even the smallest, cheapest car has reverse look back, it's got cameras, it's got automatic seats, all these different things. It will happen, there's no doubt about this. But I don't look at it from the problem of, is it a data issue or is it a robotics issue? Actually, I think the bigger problem with self-driving cars is the ethics. It's the ethics of when the car is driving along and it has no choice but to crash into somebody because an accident is going to happen. Who's in fault? Whose problem is this?
Yeah,
and this is ethics, and this is a huge problem. And I think this is actually the biggest problem in self-driving cars, is who makes this choice. And when the robot makes this choice, who do we blame? Do we blame the robot, or do we blame the designer? Do we blame the developer or the machine learning specialist who put this algorithm together? Who will the insurance company blame? So this is the bigger question, I think, to ask in robotics.
Have you thought about it? Do you have any idea how to solve this problem?
I don't think there is any better answer. I think that humans, we like to think that we are very good at making choices, but actually we're not. We're actually quite bad at making choices. And I think that all things considered, if you had a car going towards maybe someone older and someone younger, who would you knock down? Who would you kill? You know, this is a choice that has to be made. Somebody has to make it, and there is an algorithm there that will do it. So, I don't think there is right or wrong. We just have to judge the situation when we see it at the time. There's all sorts of factors that help these decisions.
Okay. At the World Economic Forum in Davos this year, fourth industrial revolution was one of the hottest topics. The thesis was that in the nearest future, in 5 years, 60% of professions will be gone because of robotics. What do you think about it?
It's probably true. Maybe it won't be as high as this quickly, but certainly within 10, 15, 20 years, we will see an absolutely dramatic change in the work that people do and the way people spend their time. We only have to look at history to teach us what's going to happen in the future. When we look at when the Industrial Revolution came along and the mechanization of things, how suddenly so many people were out of their job. So many people who did things by hand for so many years, and then a machine came in that could replace this. We had people who by hand made cloth for many years, and they were weavers. We don't have these people anymore except as a hobby, right? So machines do this. So it's exactly the same thing, except things that maybe require more human input, things that require subjective opinions. These are things, and these are the types of jobs that will always last. We're already seeing in America, for example, there's at least one company that is already using data science, predictive analytics and machine learning to look at a court case before it goes to a judge, and it is getting something like 90% predictability of whether it will win or lose. So does this mean we will have less lawyers in the world? Hopefully, because the world needs less lawyers, right?
That's true. I can agree with that.
So the thing is that it is up to society in general to be able to look ahead and decide again ethically, what do we want to do in the future? And do we want to allow these things to happen? Is it all about profit, or is it more about community and about people? And I think there's a lot of learning in here to be done, and I think that a lot of people, the people who vote the governments into office, who go and have talks about these types of things, like in this forum, we need to talk to our leaders and our politicians and our governments and say, listen, this is coming, and we don't want this all to be about profit. This must be about humanity, and it must be about the environment, and it must be about making these things better for everybody. So can we please pull together and make some decisions now that will help us do the right thing in 10, 15, 20 years' time? Because it's not just about you and me, it's about our children and our children's children. And if we're not careful, the robots will take over. And then we're done.
Okay.
But I, for one, welcome our new overlords.
We are on the Code Europe. How do you like our conference? And what was the most surprising thing out there?
I think, first of all, I've been to a number of conferences this year alone, and the Code Europe conference is incredibly professionally run. You can be proud of what you have done. It's a big achievement. The organization that you have and the automation that you have around the organization is a credit to you and to all of your colleagues. I think to host such a large conference and pull it off so smoothly is very, very commendable. I was also interested in the very wide range of topics, the very wide range of speakers that you had in, not just about code, but about legal aspects of the profession, about ethical aspects of the profession, and other open discussions. It was quite interesting to see this. And what I do look forward to is seeing what you're going to come up with next year, because you're going to have to do better than this, and you did this really well. So it'll be interesting to see how you can get better again.
Did you have any opportunity to watch other speakers' lectures?
I did. I went into 2 lectures. Unfortunately, I don't speak Polish, so I had to come back out of those again. But I did catch part of one of the ones on Spotify that was very interesting. And that in turn has led me to go and look up Spotify Labs and start reading some of their information and learning that they've put out in the world. And this is one thing that would be a good message that I'd like to get across. The reason that I came here to speak today was to share knowledge. And I think as a developer and an IT guy, there's not one day that goes past, but I don't Google up, how do I? What is the answer to? And always I go to Stack Overflow, CodeProject, C# Corner, one of these different places. The information is there. And somebody writes this information, okay? And we get stuff into our head and we say, thank you very much, and we go and do our job. It's really important that we give back to community. It's really important that we put information out there ourselves. So if you if you take, try and do some giving back as well. Even if it's only a small few answers on Stack Overflow, or if it's a really detailed article on one of the other websites. So it's really important to do that for future engineers.
Thank you for your time and thank you for this talk.
You're very welcome, and thank you for inviting me.